numerical methods too. So in this section we will see numerical solutions of algebraic and transcendental equations. We know what meant by algebraic and transcendental equations. So the equations involving algebraic functions, polynomials like that we call algebraic equations, and the transcendental one means trigonometric functions, exponential, logarithmic functions are involved in that equation. We call transcendental functions. Okay, so in that we will see three type of solutions, numerical solutions of the algebraic and transcendental equations. So one is the method of bisection method, and the second one is false position method, and the third one is numerical absence method. Okay, so we have come across, we will see the three methods to solve these algebraic and transcendental equations. So we will see first method, that is numerical bisection method of bisection method. Okay. So the method goes like this. If a function f of x is a real valued function, if f of x crosses somewhere at a point in the x-axis, so to find the value of x where it crosses x-axis, for that we choose two values. Initially we choose the two values. One is x0, we call that as x0, and x1. So the values are chosen so that the values must be closer to the curve where it crosses x-axis in either side, either it is positive side or a negative side. Okay, so how do you will cross the how do you will choose the values means, so you have to choose the values of x such that the function f of x, the initial value f of x naught must be either it is positive or negative, and similarly f of x1 is either positive or negative. So you choose the values such that f of x0 and f of x1 are both in opposite signs. In the sense, f of x0 is, suppose if you take as f of x0 is positive and f of x1 is negative, means the curve grows like this. Okay, so here we will see the curve how it is. So the f of x0 is negative, it is below the curve, and f of x1 is positive. So here it crosses x-axis. This is the value where we require to find in this method. So by the method of bisection, we will see, we will take the two values, this is x0 and x1, we will add these two values and divide by 2, we get the bisection value. It is not nearly the same, but it may be approaches to the value. Okay, so we will see the first approximation as x2 is equal to x0 plus x1 by 2. Okay, so then you consider the value of the function at this value, the value of the function at x2. So the f of x2, either here we getting the negative sign. Suppose if you get a negative sign, then you choose the values of alternate among three values, among three, f of x0, f of x1 and f of x2. Among these three values of the function, you choose the alternate signs. Okay, so here you choose, you see here it is negative and f of x1 is positive and f of x2 is negative. So then you consider the alternate signs. So the f of x1 is positive, here is f of x1 is positive and f of x2 is negative. So therefore we choose the next approximation will be considered between the values x1 and x2. So x3 is equal to x1 plus x2 by 2. Okay, so you take the half of the values and summing those two values, divide by 2, that is the third value, f of x3. Similarly, you find the value of x3, the functional value at x3. Either if you get a values of positive, then similarly as proceed in the same way as we done in the previous. Okay, we choose the fourth approximation as x4 is equal to sum of these two values, and the proceeding in the same way. We get the values of x5, x6, x7, x8. So all the values goes on changes. So these values converges to a one single value